Okay. All right. Macy, do the ring for me.
Blank is used to determine absolute age. I got
All right. And that is the correct answer, as you can see by the check mark. And go ahead and read me the objectives down there on the bottom.
I will simulate a half-life by doing an activity.
Okay. And if you want to, you can do that. And hit reset. There you go. Alright, so we are going to do an activity, but before we do that, we're going to do just a little small refresher on what radioactive decay and half-life is. Some elements have forms, and they call these forms isotopes, that have unstable nuclei that have a tendency to change or decay. Well, first off, what's nuclei? Who can tell me?
A nuclear.
More than one nucleus, okay? So, in these particular forms of elements, the nuclei are unstable. So that means that they're not going to stay the same. Something's going to happen to them, they're going to change, or they're going to decay. Many elements have some isotopes that are unstable, essentially because they have too many neutrons to be balanced by the number of protons in the nucleus, okay? And what's our charge for neutrons?
Negative.
For neutrons?
They're in the middle.
Neutral, okay? Neutron, neutral. But our protons are what? Positive, okay? So, in our unstable elements, there are too many neutrons to be balanced by the protons. So, each of these unstable isotopes has its own characteristic half-life. And for those of you that may not remember, or does anybody remember what half-life is? No? That's the time it takes for half of the atoms in the element to decay. Okay? So each of these unstable isotopes have different half-lives. They're all characteristic to that particular one. Some half-lives are several billion years long, and others are as short as 10,000th of a second. So there are some elements that have gone through several half-lives since we've been in the class today. Where the amounts of parent and daughter isotopes can be accurately measured, the ratio can be used to determine how old the rock is. So, your original is your parent.
I see. No, I'm confused.
What are you confused about?
If it's a half-life, then how can it go through more than two?
Because it cuts in half. The original goes to 50% of the parent, and then the next half-life cuts that 50% in half, so it's half of 50%. Well, what's half of 50%? 25. So, and then the next half-life cuts that 25% in half, which is what?
12.5.
12.5. So, see, it keeps cutting half in half.
So this is it.
It's gone. It's completely decayed. Well, it's not dead, it's just completely decayed. So, all that you've got left is the daughter isotope.
So is it kind of like saying that, say my parents are like Indian, then I'll be 50% Indian, and my children will be 25% Indian.
Kind of.
She did.
Yeah. It doesn't follow exactly the same thing because genetics is a little bit different, but it's close. It's a similar concept. Alright, so your parent, like I said, is the one that we start with before it starts to decay. And then once it does decay and goes through its first half-life, the change is the daughter. And for every time it goes through a half-life, there's another daughter. Okay? So what they can do is, if they have rock that they want to try to figure out how old it is, once they determine what the parent isotope is, as long as they know what the half-life of that parent is, and they can measure how much of the parent is in there versus how much of the daughter is in there, that will tell them how old that rock is. Because they can say, well, we know that, let's just say, for example, the half-life of the parent is 1,000,000 years. Okay? And if they know that the half-life of the parent is 1,000,000 years, and they've got this amount of parent and this amount of daughter, they can do a formula to calculate how long the decay's been going on, and that will give them an idea of the actual age of the rock. The atomic nuclei are held together by an attraction between the large nuclear particles, which are the protons and the neutrons, and that's known as the strong nuclear force. Okay? The problem is when you end up with one that becomes unstable, the strong nuclear force can't hold it together. So the number of neutrons needs to be at least equal to the number of protons in a nucleus, and if not, or if it's more, the nucleus might be unstable and decay can be triggered. So we're going to talk about U-235, and that's an unstable isotope of the element uranium. And the little activity that we're going to do in a little bit is going to be kind of simulating what this would go through as it's decaying. It's got 92 protons and 143 neutrons in the nucleus of each atom. So, do we have an equal number of neutrons and protons? Which one do we have more of? Neutrons. And what did we just learn about that?
That it triggers
force.
Okay? The force won't be holding it together because you need to be more close to equal when it comes to neutrons and protons. So, and if you have too many neutrons, then you're going to end up with decay being triggered at some point. So at any moment, there's a small chance that each of the nuclei of U-235 will suddenly decay because we've got too much of a discrepancy between the protons and the neutrons. So the chance of decay is very small, but it's always present. And it stays present because the nuclei don't wear out, okay? They don't eventually just give up and say, oh, I'm so tired of done being a nucleus and die, because they're not organic, so it doesn't work that way. So they don't ever tire out. They stay there indefinitely unless decay happens. Now, if it's already happened, then it's not going to decay. It's going to become stabilized. But if it hasn't already happened, then there's always a chance it's going to happen in the future. Very careful measurements in laboratories made on very large numbers of U-235 atoms have shown that each of the atoms has a 50-50 chance of decaying during about 704 billion years. Okay, so that would be the half-life of the U-235. That's how long it would take for half of the atoms of one of those to decay into its daughter, which we're fixing to learn about. Through a series of changes within the nucleus, when U-235 decays, it discharges several particles and ends up, instead of the 92 and 143, now you've got 82 and 125. And this is considered a stable condition and doesn't change further. So even though there wasn't a great reduction in the discrepancy between the neutrons and the protons, it was enough to stabilize it. Okay? But it's changed it, because how many protons you have determines what element you have. So since we've changed our number of protons, it's decayed into something new. And in this case, it decays into lead. And the symbol for lead is Pb. Okay? The protons, which are 82, and the neutrons, which are 125, total 207. So this isotope is named Pb207. Okay? Now, it's not exactly the same as just lead by itself, because just lead, if you just see this symbol alone, has a different count. So it's a different isotope. Same element, just a different isotope, because it's got a different number of neutrons and protons. So anytime you see a number following it, that's what it's talking about. Pb207 is the daughter product of U-235 because the change occurring in the U-235 isotope created it. So U-235 is considered to be the parent. The change is always the daughter. I don't know why they call it daughter, but that's what they call it. Okay, so anytime you see parent and daughter, when it's talking about isotopes, it's talking about the radioactive decay, where the parent has become unstable and it's decayed into its daughter isotope. So during that 704 million years, half of that U-235 atoms that existed at the beginning of the time will decay to Pb207. So that is the half-life of U-235. And then over the next 704 million years, the half that was left over will decay again. And then another 704 million years, the half that was left over that time will decay again until there's finally, eventually, and it will take a long time, there won't be any left. It'll all be the daughter. Yes.
So is Pb207 the daughter
Yes.
of U-235?
Yes. Okay.
Is U-235 always going to be like the father?
Well, the parent. In this pairing, yes. But it's possible that there could have been a parent that created U-235. Possibly. Okay? Alright. So that's just kind of the basic concept of how radioactive decay works and how scientists can use it to determine the age of a rock. because they can take this information, because they know how long it takes for this uranium, for example, to decay into its daughter. And they can use that information by testing the layers to determine how much is there, and then use that, compare it to the half-life, and say, well, this rock can be so many billion years old because of that. Okay? Now, what we're going to do is an activity that's going to kind of simulate how the half-life works. And in order to do this, I'm going to end up splitting everybody up. Okay? And you're all going to get your own M&Ms, and then we'll go through the process. But I'm going to go ahead and go over all the instructions first so you can understand what we're doing before we split into groups and get working on it. Yes? You don't have to if you don't want to. It's the option that will be there, though. Okay, so every group's going to have a bag with 100 M&Ms in it. And the very first thing you're going to do after you get your group and we get settled is you're going to have 2 paper towels. One of the paper towels is going to be for your parent, and one of your paper towels is going to be for the daughter that it decays into. Okay? So the very first thing you're going to do is pour all of your M&Ms onto the parent and place them all with the M facing down. Okay? So we're going to call that the face down position, since the M is facing down. Once you have them all facing down, that represents the parent isotope, because at that point, they're all parent. Okay? Because the M down is going to be the parent. Once you've got them all representing the parent, then you're going to put them back in your bag and shake it up. And then pour them back out onto your parent paper towel. Do not turn over any as you're spreading them out. Okay? Because you're going to have to spread them so you can see if they're showing the M or not. But when you're spreading them, be careful and don't flip one over, because that's going to mess up your results. Okay? Just spread them out however they fell. The first time that you do this represents the isotope's first half-life. All the pieces that land face up, with the M facing up, would represent the daughter. Okay? And that's the change from the decay. So you're going to take all of those pieces that land face up and move them to the other paper towel, which is for the daughter isotope. And they're going to stay there, because at that point you're done with them until we're finished with the activity. Okay? Then at that point you're going to count how many is left on your parent paper towel. And I'm going to have a table up here, and each group is going to tell me how many parents they have left, and we're going to record it in our chart. Okay? And then you're going to take the parents, put them back in your bag, shake it up, pour it out, and do that process all over again. Anything that lands face up, you're going to move to the daughter paper towel. You're going to count the parent, let me know how many it is, and then do it again. We will keep doing this 2 ways. Either until you get to none left, or until we've done it 9 times. Okay? So we'll have to see what happens. You may make it all the way to 9, and you may not. We'll just have to see. Alright? Does everybody kind of understand the basic process of what we're doing? I'm going to leave this up here until I need to put the chart up here. Does everybody understand? Kind of, at least. Alright. Now, I'm going to do a little bit of consolidating with your groups so that we have at least 4 in most of our groups. So I want you 2 to move over here. We're going to actually end up with your group. No, it's not. Alright. Courtney, if you will move over there with Valerie's group. Peyton, if you'll come up here with Tucker's group. And Blake, if you will move over here with okay? Now, kind of clear your space off in the middle if you want to push your book off to the side or the end. So it's kind of middle space to put your paper towels. And if I would have a volunteer to pass the paper towels out for me. You need to stay quiet so you can hear the customer. Alright, 2 per group will be perfect. Yeah, that's 1. Let's see if I get 2 at a time. Alright, now while Callie's passing out the paper towels, I'm going to come around and let everybody get hand sanitizer. That way, before you start touching the M&Ms, your hands will be clean. And that way, when we get done with it, for those of you that want to eat some of them, you won't be worried about the fact that your classmate has been touching them, because their hands will have been clean before they do. Alright, now who can tell gonna be the first thing that you do when I give you the bag of M&Ms?
You pour it on the thing,
Okay, you pour it onto one paper towel,
face down,
and then what do you do?
face down.
Put them all face down.
Then you put it back in the bag.
Okay, and then you put them back in the bag. Alright, so y'all got the first part. And I had some help this morning, some of my first time students. Alright, so go ahead. Now you're going to need to spread your paper towel out. So make sure that it's opened all the way. And please remember to keep our voices lower so that I don't have to get too loud to be heard. Okay, all of them in, facing down. Not one. Yep, because remember the end facing down is the parent. And I'm going to go ahead and turn the other lights on so you guys can see better. They're supposed to be pouring those out on the paper towel. With the end facing down, so flip over any that's not. Okay, now after you've got them all with the end facing down, this is your parent. And as of right now, it's whole. Okay, it's 100% parent. But we're about to change that. Now, this group over here has figured out the easiest way to put the M&Ms back in the bag without spilling them. Make kind of a little folded up funnel with your paper towel and pour them in there. Now you're going to shake them up. Pour them back onto your paper towel, but this time, any M&M that lands face up, you're going to move over to the other paper towel because it's the daughter. Okay? So put them back in your bag, shake it up.
Stop it.
Spread them out, but be careful not to move any from the way it landed. And then anything that's in up, or face up, put on your other paper towel. For the first time, anytime you do it like this, it's fine. It's after you pull them back on here that you don't want to change the weather up. Pour back out.
These are all of them down.
You want to do it again? Not yet, because I'm going to have to record your numbers. Once you have them separated, just wait for a minute so everybody can catch up.
You count the daughter or the parent?
You count the parent, not the daughter. So anything that has an M face up, put on the other one. And then after you're done with that count, you have what's on this one. Alright. Let me erase. Why don't you draw a circle around it?
Seems like there's a lot more.
Apparently I don't know how to do it. There we go. Okay. Alright. What did you guys get for your parent for the first time? This one's a lot.
Wait,
Okay, I got 49. Alright, now after I've recorded your number for the first one, you can repeat the process with what was left of your parent. Now remember, your daughter isotopes, you just leave alone. You're done with them for the time being. Alright, 51.
Parent.
Alright, y'all can go ahead to your next step. Now don't move forward until you have told me how many you have on your
Do
parent.
we leave the daughters alone?
Yes, you leave the daughters alone. You are done with them until the end of the activity. Right. Alright, now you have to count your parents. How many do you have? I think I caught you. Y'all should put it in there and then we would know y'all come on the other side.
Oh, just the
Or do we
daughters.
count them?
Just the parents.
Yeah, just the parents. At this point, the daughters, whatever daughter you had from the first time, we're done with them. They're going to stay on their paper towel and not be used again for that activity.
Wait, so we don't add our new daughters to the old daughters?
Yes. I just mean your old daughters are, we're done with them, they're just gonna sit there.
53?
Okay, go to the next round.
23.
That means you'll have them take one. Did you forget to count? Okay. Now, after you count in a second, but let me know how many parents you have before you move on to number 3, so we can record it in our table. No, I'm doing it. You just tell me how many's in there. 19 for the third one.
We've got 12.
Y'all already done it 3 times?
Yeah,
We count how many we take away.
Awesome. Stay.
So,
11. Okay, hang on right there. Don't, just wait just to count that one. How many?
We have 5 on our fourth one.
Hang on, hold on that number. Okay, I'll shout it at me at once or I won't be able to get them down. Whoops. Okay. How many? Oh, this one? Wait, the next one? Yes.
Yeah, no, we have 3.
Oh,
And
eleven.
then that's third.
Okay.
We have 3 on the fifth.
Okay.
Now we have 2.
5, 6, 5, 7. How many? 5?
We have 1 left.
And how many parents did y'all get that time on y'all's next one? Oh, we have 2.
Let's go. 1. Yay! 0.
We got 12.
13. We have 13. We have 2 again on the 7. Hang on, y'all have 2. 13. We have 12. Okay, we have 2 again on the 8th one. Okay. This one doesn't have an M on it. It doesn't have an M on it. Okay, so we have a defective of an M. Alright, so just, no, just guess the deflated by substances. You've already said
Zero,
zero.
zero.
0. Can we eat them? Just like that. We have 5. No, 7.
Oh, 7.
Okay. We have 5. 7. Alright, now, for you groups that are done already, so while we're waiting on these other 2 to finish, if you guys have a phone with a calculator, we need the class average for trial 1, trial 2, trial 3, trial 4, so those are all complete. So,
I'll do trial 2.
I did
I'll do trial
I did
4.
3.
I got 2.
Okay,
3.
just tell me across. Trial 1, trial 2.
3.
I got 1. Alright, I got it first.
You already got it?
I got 4.
2.
Alright,
Wait, no, we're the other group.
yeah, we're the.
For number 2, it's 25.5.
What?
For,
2.
hang on. We have 3.
And then 1.
For number 4, I got
Alright, y'all can't all holler numbers out of it, because if you do, I'm not gonna know where to put them.
Number 2
So
plus
just raise your hand so I can call on you. 3. Okay. Number 4 is 7. The class average. Alright,
number 2 is 25.5.
so that would be, we'll round it up to the whole numbers, 26.
For number 1 is 52.
52. Okay. 1. We had 1 and then 1.
And then 0.
Okay.
Can we even know?
Just wait a minute. seem to be done. Samantha?
Yes. No. Share some.
No, man.
Oh my gosh.
I love you guys.
And you might want to put that in the side some, but zero. Oh, we already dropped it once, so I'd already drawn one. Okay,
It's the best group.
number 5 is 7. Alright,
2, 7, 7 divided by 3, 3.5, so 4. Then 2 on the next one.
oh, it'd be 3 because it's 2.5. Because half of 5 is 2.5, so it'd be 3. But you're not doing them, just doing these, you're not doing half, you're doing 4. I know, but it's 2.
No, but it's 5, so 5 divided by 2.
5 divided by
How's about
4.
You had to divide by 4.
Would
Oh,
be 1.
oh, then that, the other one's not 7, and the other one's not 4.
These 2?
Yeah.
Well, renew them and tell me what they are.
I don't know.
5 plus 3 plus
14 divided by 4.
What's number 8? Number 5 is
3 divided by 4.
number 5 is 4.
What if they all landed
Number 8 is 1.
in the very first time?
And then, number 6 is 1.75, so it'll be 2. Okay. Alright, so now, this is what we're gonna do. And as far as the M&Ms go, you guys can kind of split them up within your group however you want to. And if you want to kind of snack on them as we're doing this next part, that's completely fine. Alright, the next thing that we're going to do is, you guys are going to graph the results that we've come up with. And I'm going to have to switch it over to, because I'm going to do the graph with you, we're going to kind of do it together. So that's not going to step on the screen, but I can tell you your numbers. And we're graphing 3 different things. You're graphing the numbers that your individual groups came up with. We're graphing the class average. And then we're going to graph what half of the parent would have been the percentage. To see how they compare. Now you're going to need colors out of your caddies. If you set your caddy on the floor, you might want to pick it up. You're going to need 3 different colors. Okay? So try to choose 3 that are not too similar to each other.
What are your most ugliest colors?
And then you need to decide, y'all need to listen so you can hear what we're doing. You need to decide which color is going to represent which thing. Like, for example, I've got blue is my first one. And since you can obviously tell by looking at it that it's blue, it's going to be the group. And then my next color is pink, and it's going to be the class. And then my last color is green, and it's going to be the half-life percentage, so I'm just going to put the HL percentage. Okay? So that gives the key to my graph. Alright. Now, everybody is going to start at 100. I think it kind of cut the one off, but this is 100 up here. And this is our starting point, because how many M&Ms did we start with? 100. Okay? So, everybody's starting place is here. Now, the first thing that you're plotting is your individual group. So, I'm going to tell each group what your number was for each trial. If you look down here, that's the bottom. That's the number of trials or half-lives that we did. Starting 1 and going all the way up to 9. So everything that you plot is going to be on one of these lines going up and down. Okay? Alright, now group 1. And I'm going to plot yours on the graph so you guys can kind of see how this is done. So for group 1, your first one was 49. So you're going to find 49 and put a dot on the line where 49 would be. Okay? Group 2, yours was 53. So you need to find 53 and plot it.
We're group 3, aren't we?
Group 3, Samantha, you guys are group 2.
What
Y'all are 53.
53.
Tucker's group is group 3, you were 53. And Abby's group is 4, you had 51. Okay, so that was your first one.
So 4 is 51.
Alright, for the second run, group 1, you had 26. And since I'm plotting yours, I'm going to put that into line 2 here. Group 2, Samantha's group, you had 27. Tucker's group, for the second run, you had 26. And Abby's group had 23 for run 2. Okay, for run 3, Jordan's group had 19. And since I'm plotting yours, it's going to go right under that line there. Samantha's group had 13. Tucker's group, you had 12. And Abby's group, you also had 12.
Where were we supposed to put it at?
Even with, see at the bottom where it says number of runs?
Yes.
Okay, that was run 3. So that one should be on the line 3, wherever your
I did it wrong.
number equals to.
Do we change colors each time?
This is like.
Not yet.
I did it wrong.
Stay that same color because this is your groups. Alright. For run number 4, Jordan's group had 11. So I'm going to plot that, it's right above that line. Samantha's group had 5. Tucker's group had 7.
Do you have a new thing I can have?
Hey, we're gonna-
She put it in my car on trial one.
What was our third one?
I'm putting all of ours on trial 4.
What was run 2?
We got
And
25.
for run 4, Abby's group is 5.
What was our
If you have a question, raise your hand so I don't have people yelling stuff out. Okay? For those of you that maybe did it wrong to begin with there. Blake,
What was our number 3?
12. Abby,
Will you retell all of them?
the first one was 51.
Okay.
The second one was 23.
Okay.
The third one was 12. And the fourth one was 5. Okay. Is everybody caught up?
Yes.
Alright. Now we're on to run 5. And Jordan's group, you guys got 5 on that one. So you're going to be kind of halfway on that line. Samantha's group got 3. And Tucker's group and Abby's group also got 3 for that one. Alright, for run 6, Jordan's group had 2. So we're going to move down that line a little bit. Samantha's group got 1. And Tucker and Abby's group both got 2. For run number 7, Jordan's group got 2 again. And I know that might possibly have been due to that one not having an M on it, but we're going to go with what we got. And then all the other groups got 1 on that one. For run 8, again, Jordan's group got 2. Tucker's group on that one got 1, and Samantha's group and Abby's group got 0. And then on run 9, the other 2 groups got 0. Alright, so now, once you have your dots plotted, you need to take that same color and connect them, starting up with 100, which is how many M&Ms we started with. And then connect all of your dots to make your first line on your graph. We're going to have to speed up, or we're not going to get done here. Ow. Alright. Now, the next 2 sets of numbers, everybody's going to be doing the same ones. Okay, so everybody can watch where I'm plotting. We're going to do the class average next. So whatever color you wrote down up here to do class, that's what color you need now. This is our average. Again, we all started with 100 to begin with. So our first dot is 100. Now, our first run, class average was 52. Second one was 26. So that's right on top of group 1's dot. The next one was 14. Number 4 was 7. 5 was 4. Right there. 6 was 2, which for group 1, that's going to be right on top of your dot. 7 was 1, and that'll be right on top of some of y'all's dots. 8 was also 1, and then 9 was 0. So once you got those, you're going to draw this line, and I'll kind of this a little bit, to connect the dots for that color. Now, is there a great difference here? No. Okay, 3 was 14.
Ours is like almost the exact same.
Uh-huh,
What was number 3?
14. Alright, really quickly, we got one more, and you're going to have to listen carefully. This is half-wise, so this is just cutting everything in half to begin with. So we started with 100, what's half of 100? 50, so that's where 1 would go. What's half of 50?
25.
Okay, so that's where 2 would go.
Wait, hold on. You're
Wait,
going way too
wait,
fast.
wait.
It's 60.
Yeah, I know, but we're about to get caught by the veil, that's what I'm trying
50
to
and
go.
25.
Oh, half of 25 is
14.
12 and a half.
So what was 14?
Alright, so that's going to be,
Is that the second row?
6.
12.5. Yep.
alright, 12 and a half, half of that is 6 and a fourth, no, 6 and,
Just say 6.
yeah, 6 and a fourth is what it is. So 6,
Number 4 is 6.
yep. And then you're at 3 something, and then 1 and a half. And then at that point, you're so close to the line that you might as well be on it all the way down.